Welcome to my professional mathematics corner. I am Mukul Sarma. Today I shall discuss about solution of some problem in miscellaneous exercise chapter number 5. Last class also I have discussed some problem. Today also I shall discuss some problem. That is a first problem, that is question number 10. It is if z1 is equal to 2 minus I, z2 is equal to 1 plus I, find z1 plus z2 plus 1, z1 minus z2 plus 1. That was solution. At first we have to put the value of z1, z2 here. So like z1, z2 plus 1, z2 1, z1, this is z2 plus 1 modulus, this is z1 is 2 minus I, z2 is 1 plus I plus 1, okay. z1 2 minus I, z2 we have to keep value of z2 within the bracket because minus sign is there, therefore 1 plus I plus 1, that is modulus. Now this is 2 1 1, that is 2 1 3, this is 4, that is 4, and I is going to cancel. This is 2 minus I, if we remove the bracket, minus 1 minus I plus 1. This is 4, this is 2 minus 1, 1 plus 1, 2, 2 minus 2i. We can make it in a plus ib form. That is 4 plus I0, this is 2 plus I minus 2. This is a plus ib form. This is also a plus ib form. This is also a plus ib form. Therefore we can write this as 4 plus I0 modulus 2 plus I minus 2, so modulus, because z1 z2 modulus, it is a property of modulus, z1 z2 modulus is equal to z1 modulus z2 modulus. Therefore we can write this is 4 square plus 0 square root over, this is 2 square minus 2 square root over. From here we can write this as, this is 16 root over, this 4 plus 4 root over 4, this is 8 root over, is 4, we can write is 4 into 2, therefore this can be also written as 4 by 2 root 2. We can rationalize this, this is 2 by root 2, that is 2 root 2 by root 2 root 2. In this way we can rationalize, that is 2 root 2, that is 2 root 2 root 2 2, this is cancel, and this is root 2. Therefore value of z1 plus z2 plus 1, z1 minus z2 plus 1 is root over 2. This is next problem, that is also this. If a plus ib is equal to x plus I whole square, 2x square plus 1, prove that a square plus b square is equal to x square plus 1 whole square, 2x square plus 1 whole square. Solution. Given a plus ib is equal to x plus I whole square, it is 2x square plus 1. This is, we mark this is 1. Therefore, a minus ib, if we take conjugate, a minus ib x minus I whole square, 2x square, taking conjugate both sides. This is number 2. Multiplying 1 and 2. Multiplying 1 and 2. A plus ib, a minus ib. Therefore, x plus I whole square, 2x square plus 1, x minus I whole square, this is 2x square plus 1. Therefore, x plus 1, you can write x plus I, x minus I whole square. And this can be written as 2x square plus 1 whole square. And this can be written as a square minus ib whole square. Now this is a square plus b square, because as I square is equal to minus 1, and this is minus 1, this is plus. Here is x plus I, x minus I, x square minus I square whole square, 2x square plus 1 whole square. This is x square, I square is equal to minus 1, minus I square is plus 1 whole square. This is 2x square plus 1 whole square. Proved. This is the problem. Next problem that is I want to discuss, that is also most important for examination point of view. This is find the modulus and argument of complex number. That is solution. Let z is equal to 1 plus 2i, 1 minus 3i. It is not in the a plus ib form, so we have to make it a plus ib form. Therefore, to make it a plus ib form, we have to multiply denominator. Conjugate of 1 minus 3 is 1 plus 3i, and this is also to be multiplied in the numerator also, 1 plus 3i. 1 minus 3i লগত 1 plus 3i ইনটু কৰিব লাগিব, আৰু সেইখিনি 1 plus 3i টো আমি 1 plus 2i লগত ইনটু কৰিব লাগিব। এতিয়া 1 square minus 3i whole square, a square minus b, a minus b, a plus b, it is a square minus b square formula. Now we have to multiply this. Eto ami puron korim ekhini 1 3i, that is 1 into 3i, 2i, that is 6i square. It is 1 plus 5i, that is minus 6 it will be, because I square is minus 1. Therefore, it is minus 6. It is 1 plus, that is 9. 3 square 9, I square, that is plus. 1 minus 5. 1 minus 6, this is minus 5 by 10. This can be written as 5 by 10 I. We can 1 2 1 2. This is minus 1 by 2 plus 1 by 2i. Therefore, it is A plus IB form. This is here. Therefore, A is equal to minus 2, B is equal to minus 1 by 2, A is equal to minus 1 by 2, B is equal to the modulus of Z. What is the modulus of Z? Now, modulus of Z is equal to A square plus B square root over this is A square is minus it is square is 1 by 4 1 by 4 1 by 4 1 by 4. This can be written as 2 by 4 root over 1 by 2. This is 1 by root 2. This also can be written as 1 into root 2 by root 2 into root 2. If we rationalize this part, this is root 2 by 2. This is the modulus of the complex number. Now argument. What is the argument? ARGZ. Now ARGZ. Now ARGZ, argument of Z. This is, it is A is negative, B is positive, so it is in the second quadrant. So principal argument is pi minus tan inverse B by A modulus. Pi minus tan inverse B means here 1 by 2 minus 1 by 2 pi, that is tan inverse 1 modulus pi, since it is modulus tan inverse 1, we can write tan inverse 1, modulus of minus 1 means 1. Therefore pi minus tan inverse 10 pi by 4. Therefore we can cancel this 10 inverse and 10, pi minus pi by 4, this is 3 pi by 4. This is the argument of the complex number, and this is the modulus of the complex number. So this is all about the problem. Next class also I shall come with some more problem.